Hello, you lovely lot. I'm Teacher Jess, and welcome back to Jura Cafe. How you doing? Hopefully well. Got your coffee? My one today is just add coffee. Just add coffee. Mm, have a normal human being. So I hope you were doing well this last week. Uh, I was. I decided to take a topic that was more relevant for the grade 12s. They're getting ready for their exams. So I thought we could take a look at rivers. It's just once again, it's just an intro to rivers, so we're not going to get into all of the most technical stuff, but we can maybe just look at understanding important terminology of rivers, some of the processes around rivers, and some of the really beautiful landform features that they create. So this would also be referred to as fluvial geomorphology. So it's the geomorphology section. Okay, my screen up. There it is. Okay, so rivers and all things rivers, at least intro to rivers. ISIS not. There we go. So unfortunately, we need to start with all of the terminology first. So we need to know what all of these words mean so that when we use them in context and in diagrams, it makes more sense. Okay, so the first one, or I actually say the first two, is they can often get confused, and that's drainage basin and catchment area. So to explain catchment area is the area of land where if there's rainfall within that area, it will feed into the river. Then the drainage basin is basically the entire network of river systems that contribute to the main river. And the reason why these can be a little bit confused is because they can be the same area. So the catchment area and the drainage basin can be the same space. It's just the function. It's the term that we describe for the function. Right, so drainage basin is everything that contributes, the systems that contribute to the main river, and then the catchment area is the space that actually catches the rainfall and feeds the river like that. Okay, the source is where the river begins. It's where it gets its water from. We're going to notice that there are different types of river, all based or named differently based on how they get their water and how consistently they flow. So a tributary is a little stream that would contribute to the river. So you can notice the actual word tributary, contributing. So it contributes to the main river, it provides water to the main river. The mouth of the river is where it ends. You'll also find landform features there, like a delta. And then confluence. So confluence, you can think of um, combination. No, that doesn't work. Not even combine will work. Um, but basically, you've got two rivers that are brought together. They're combined, and they are fluvial systems, hence the fluence. So wherever you've got two rivers coming together, and I'll show you this on a diagram a little bit better, we've got two rivers coming together. That is your confluence, the point where they meet. Okay, now with the confluence, you'll also tend to find a interfluve. Interfluve is the space between the two channels. And then finally, watershed. Watershed is the boundary of the drainage area or the catchment area. So let's just show you on a diagram because then I think it will make more sense. So if these are the little rivers that feed into the main river, it is a tributary. There you can see the name, tributary. where it merges with another tributary is the confluence. And then this space in between it would be the interfluve. Okay, the drainage basin is this entire area. All of this is contributing water to the river, and it's marked off with the watershed. So any rainfall that happens on this side or any water that is found on this side would contribute to this drainage basin, but if it was on the other side of the red line, it would be in the other drainage basin. Okay, so it starts at the source over here and it ends by the mouth. Not all rivers actually end in the sea or even lakes. There are a very small handful that actually end in the middle of the land. I'll show you an example of that one. Okay, so this is just a side view of a river system so we can understand the processes a little bit better. This is actually supposed to be a diagram of the water cycle or the hydrological cycle. So you should be familiar with you've got water, it evaporates, it forms clouds. You've got the sun over there, evaporating water, it forms clouds, then the clouds blow onto land, and you get the rain, the precipitation, and then that will flow down the mountain and get all the way back to the ocean. But as you can see, there's many more processes, many more steps involved from that very basic little water cycle. So in some cases, it would rain straight back into the ocean. Not all of it reaches inland. We have some interception, let's say from trees over here. We've got some trees that could actually slow down and catch the water as it rains. We have some water that's infiltrated into the into the ocean. It's infiltrated into the ground. Percolation is where it sinks even deeper. Then we have groundwater flow, so it's under the ground and it moves along the drainage basin. That's an important one to know, the groundwater. And then the surface flow or the surface runoff is just anything that happens over the surface. So this is hopefully a basic little crash course of the water cycle. Right. Now we've gotten through the worst of the nitty-gritty terminology. Now I want to look at some of the different types of rivers. These types of rivers, they are classified by how they get their water. And how they get their water will also... Oh, yellow! It's your first time here. Welcome. Always nice to see someone new in GeoCafe. Oh, thank you. So we're just busy talking about rivers over here. This is supposed to help my grade 12 students or anyone doing grade 12 and prepping for their exams. I'm wanting to cover fluvial geomorphology, so this is the basics for them. So what I was just explaining is we've got your 4 different types of rivers, and it's based on where they get their water flow from and how consistently the water flows. So a permanent river, I think we can assume from the name, there's always water flowing. Periodic rivers would flow occasionally, on and off. And then I always ask my kids the question, okay, but then what is episodic? Because episodic, you can think of like a episode. It happens every now and again. And they're usually stumped between periodic and episodic. And that's where the explanation of the groundwater flow needs to come in. Okay. A permanent river. Permanent river is fed by groundwater, and the groundwater is above the river or the river bed at all times of the year. So if this is the riverbed over here, this is the bottom of the river, if you can see that. This is the groundwater during your dry seasons. You can see it's still above the riverbed, and in the wet seasons, it's a bit higher, so more water. But all year round, you have water, and it's fed by the groundwater. Then periodic means that it dries up in the dry seasons. Now, I put in there that dry in summer, that is only in some cases. Only some areas experience dry summers. Other places have rainy summers. So, but the dry season, then your groundwater will dip below this riverbed over here. So the river will dry up. And then only when the rain comes back and the groundwater starts to replenish, then the river will move again. So that's periodic. It changes with the seasons. Episodic is not fed by groundwater. It's fed by occasional rain or other sources. So this diagram, I quite like it. Down here, we have an example of permanent river. So there is always, if this is supposed to be, this dotted line is supposed to be the groundwater. So dry season, you can see it fills up there. Wet season as well fills up there. But in the second one at Y, the dry season, it just dips below the river, and the wet season, it reaches the river. So on and off, dry versus wet. And then by X, you can see it never reaches the groundwater. The groundwater never reaches it. So the only way for X to actually receive any water is if it rains or you have some other process. Yeah, I'm hoping that's making sense so far. Then we have one more type. Exotic river. An exotic river is a river that gets its source from somewhere else. Okay, that can be supplied all year round by their source. So a nice example of that is the Orange River. Orange River, very beautiful river in South Africa. So it always has water running. It's running from the source. It's not necessarily fed by groundwater, and it doesn't dry up with the seasons. Okay, I think we've covered some of the most important stuff so far. Great. Discharge is the term that we use when we describe how much water is flowing through the river. So we measure it in cubic meters per second, or we abbreviate it to cumex. So cubic meters per second, and it's how much water, the actual volume of water that is flowing past a point in 1 second. And we use hydrographs to measure this discharge during floods. I can maybe do a separate video where I explain hydrographs a little bit better, but a crash course in hydrographs is these blue bars over here. This shows us how much rain fell. So that's the precipitation. All of this is by time. So this one is hours, right? So it's from 0 hours, 10 hours, and it progresses upwards. So at a certain time, it started to rain. We got a lot of rain, peak rainfall over there, and then it started to die down. Then several hours later, this place experienced a flood. So you can see the red line over here, the discharge suddenly started to spike upwards before it slowly started to fall again. So this spike is a flood. The delay between the most rain and the most water is what we refer to as the lag time. So obviously you won't have a flood whilst it's raining. But okay, maybe it will start whilst it's raining, but it takes time for that rainwater to actually reach the place downstream. It needs time to get through all the tributaries on the catchment area. Okay, these are two different types of flow. I'll show you where we observe them when we look at the side profile of the river, but I just want to go through the names first. So laminar flow is where it's parallel. So you've got these smooth sheets of water just flowing across, and there's nothing disturbing it. It doesn't cross or change direction or anything. You can think of it like a pack of cards. The cards, they just slide over each other. And then turbulent flow is where you have this bubbling, I don't know how to describe it, stirring motion. Usually that happens if it's quite an uneven riverbed, like maybe it's pouring over rocks, or there maybe is vegetation under the ground, under the water, anything stirring it up. This isn't the only place, rivers is not the only place where we see this laminar and turbulent flow. So I found this picture as well, which is actually relating to the atmosphere. So this is relating to clouds. Here we have cirrus clouds high up there. And further down here, we've got cumulus clouds. And you'll notice that the clouds are formed depending on the type of flow that the wind is having. So if it's a laminar style flow, so it's rather smooth, then we have these smooth, straight looking clouds. Those are really cool. They kind of look like layers. But if you have a very turbulent wind, so you maybe experience it in storms or like thunderstorms or over very mountainous areas, you'll have these really cool wavy type clouds. Sometimes the clouds themselves will actually look like waves. Okay. Flow speed of a river. So we need to understand where the river flows the fastest in a given space to understand why it forms certain features. So most most of my students understand that you won't have the fastest flow against the riverbed. That makes sense. Because the riverbed, there's soil, there's debris, there's rocks and everything, and it slows down the movement. So you won't have a very fast flow over the sediment. So as you get closer and closer to the surface, it gets faster and faster. But you notice that the fastest space isn't actually on the surface. Do you have any idea why? Why is it not actually on the surface? Okay, there's a simple reason. The air provides friction as well. So there can be air, there can be wind, there can be things floating on the river, and all of that also provides friction. So that friction would slow down the flow on the top of the surface of the river. So the fastest stream is about, let's say, 3/4 or 2/3 of the way up. Oh, and this is supposed to be a cross section of a meander. I'll show you better pictures of a meander, but your fastest flow will always be towards the outside of the meander. The reason why it's important for us to know where the fast flow is because that causes erosion. Erosion is when when water or a medium transports material. Deposition is when the water drops the material. It can't carry it anymore. Hello, welcome back. Okay, so we need to know that one because those two processes make up all of the features that we're going to be looking at. So erosion, that happens when water flows quickly. When it flows quickly, it picks up the soil, the sediment, and it carries with it. Deposition is when the water slows down or is flowing slowly and it drops the material. So the faster it moves, the more it can carry. There we go. This is a nice example of a meander. So a meander is a bend in the river. And it's a very normal process for a river to meander. It would be uncommon to see a river flowing in a straight line. It's rather unstable like that. So here we can see the water flowing around the edge. So there it's the fastest. And this little yellow spot over there, that's supposed to show deposition. So this is the cross section. So this is point B. There on the inside of the bed, it's the slowest. Or the inside of the bend, it's the slowest. And the outside, it's the fastest. So here it will drop all the material, and here it will erode the material. This is also referred to as a slip-off slope, and this is an undercut cliff. If the river is flowing in a straight line, so if it is symmetrical, it will erode evenly on both sides. That's if it's flowing fast enough to erode. And your area of fastest flow won't necessarily be to the one side because it's not bending, it's not a meander. It will just hover in the middle until it gets to the next meander. I'm hoping that we can take some time and look at a few of these features on Google Earth so I can show you what they actually look like in non-diagram form. Okay, there are two types of profiles that we need to know. One is a longitudinal profile and the other is a transverse profile. Longitudinal looks at the river from a side view, so as if we had cut the whole mountain down the middle. This we refer to as the upper course. And if you can't figure it out, it's because it's the upper part of the mountain. But you knew that. Okay, so the upper course is in the upper part of the mountain. It flows down the mountain and it reaches a middle course halfway through. And at the lowest part is the lower course. That's when it starts to flatten out and it reaches its final destination, so the mouth or the ocean or a lake or wherever it will end. So this is the side view, this is where the source is, and that is where the mouth is. And a river will almost, I'll say almost always, have a profile like that. It won't have a profile like that if it's ungraded. But that is a topic for another time. Basically, what it means is if you maybe have a dam or a lake or something at some point of this river, then it has all kinds of little bends. Okay, so that's a longitudinal profile. Transverse profile. Transverse profile, I always say it's like you are in the river. You're in the river and you're looking upstream or downstream. So this water, you could say, is flowing towards you and you're looking upstream. Depending on where you are in the river course, so if you're upper, middle, or lower, this will look different. So if you're an upper, it will have a rather steep V shape. So it will erode downwards or erode vertically. If it's in the middle course, it will erode both outwards and downwards. So it has a more of a U shape. And then if it's a lower course, it's very wide and shallow. Okay, this is pretty much just repeating what I said. Okay, shape of the river profile is related to the gradient. That basically just means how steep it is. So if it's steep, like at the upper course, it will have that shape. If it's medium, it will have that shape, like middle course. And if it's flat, like at the lower course, it will have a flat, wide river profile. Okay, and that's saying the same thing. Cross profile of the upper river will have a deep, narrow V shape. Cross profile of the middle river will have more of an open V shape or almost a U shape. And then the lower course will have a basically flat, very wide profile. sorry, I realized this diagram is much more blurry than I thought it was, but I liked it because it showed the different stages. But here we go. This is the V shape. This is high up in the mountains. This is the middle course, so you've got more of a U shape. And then further down, it's a lot wider and it's a lot shallower. I hope this is making sense. Maybe it's like bringing back some memories about learning rivers and the water cycle. Great. What I like about this diagram, the reason why I put it in, is it summarizes everything that we've spoken about. We have the source and the mouth. So that's the sea, complete with little boat and everything. The river flows from the source towards the mouth. The source and the steepest section is in the upper course. The middle is your in-between section. It's not as steep, not completely gentle. And then the lowest part, the lower course, is quite flat. Okay, this is your longitudinal profile. And then these ones down here are your transverse profiles. So you've got the V, you've got the U shape, and you've got the wide flat shape. The other reason why I put this in is because it's a nice way to remember where you find certain landforms. And these landforms, that's what I want us to take a look at now. So this is the more interesting part of fluvial geomorphology. Yes, we have to know the processes before we can get the landforms because we have to understand how they're formed, but when you see them, they look really cool. Okay, so in the upper course, we've got waterfall, plunge pools, valleys, and interlocking spurs. In the middle course, we have more than meanders. I will show you some of them. And in lower course, we have oxbow lakes, floodplains, levees, and it's not on the list, but we also have deltas. Okay, so a fluvial landform is a landform that is formed because of the river flowing. So your material is weathered, it's transported, it's eroded. Just to clarify, weathering is when the rock is broken down. Erosion is when it's carried. Okay, so that's why we say it's eroding the weathered material. So it's carrying the broken material. So erosion is when you transport the weathered material, and if the river slows down, it will deposit that material. Oh, this is a lovely diagram, a lovely photo of some meanders. So this is what I meant, that it's not normal for a river to flow in a straight line. It flows, it meanders, and it bends and it goes on adventures. Okay, so we've got spurs, rapids, waterfalls, meanders, alluvial fans, levees, braided streams, oxbow lakes, floodplains, and deltas. So this I've listed as coming down the river profile. So up here by the spurs, rapids, and waterfalls, this is what you can expect to find in the upper course. Meanders, alluvial fans, and levees. Braided streams as well. To be fair, levees you can also find a little bit lower. This you would typically find in the middle course. And then oxbow lakes, floodplains, and deltas, very typical of the lower course. Oxbow lakes and meanders tend to go together, but you'll see now. And I think this is just a stunning picture of a delta. I realized I forgot to take this out. Sorry, this is a joke that I usually say for my students because we have a restaurant here called Spur. And the joke is usually, oh, you won't find a spur at the Spurs, so you can just ignore that. There we go. Okay, so a spur is a high-lying area or land that is in between the meanders. So this quite clearly shows interlocking spurs. So where you've got, it's difficult to picture it, but you've got these different areas that kind of interlock like that, and the river flows between the joints, and that's the spurs. Okay, rapids. Probably one of the most fun parts of going canoeing. If you haven't, I do recommend going canoeing on the Orange River. It is amazing. I've been down there 3 times and I never got tipped out of the canoe. Mm. Okay, rapids, they occur when you've got different types of rock in the riverbed. So over here we can see we've got soft rock and hard rock. The soft rock will easily be carried away. It's easily eroded. But sorry, come back. The hard rock isn't. The hard rock will be quite resistant, so when the water flows over it, it will carry away the soft rock and leave the hard rock cropping out. And that creates this very turbulent water over the rapids. There's that word, turbulent. Now, I always make sure to put waterfalls and rapids together because their basic formation is quite similar. A rapid is formed when we have different types, layers of different types of rock. So this is also referred to as strata. So we have a layer of hard, soft, and hard. In this case, though, it moves fairly horizontally. So it flows over the differing rocks, but there isn't a very big drop in the gradient. By waterfalls, you do have a big drop. So you've got this hard rock over here, and then you've got a soft rock underneath. So you can see it moves down that way. That will erode, and the hard rock will stay there. And then when that erodes, it will just dip the landscape down so that when the water flows over it, it drops down from the hard rock. So I included this picture because you've got your waterfall over here, hard and soft rock dropping down. And then over here, you've got the rapid. So you can see that the rock is lying in a different direction. Here, it's more inclined, almost vertical, and here it's horizontal. I have seen questions like that in exam papers, but they like to ask, how are they similar but different? So in both cases, they've got alternating soft and hard rock, but the rapids is more vertical or inclined, and the waterfall is horizontal. Okay. Are we happy so far? Are we liking these river features? This is a nice coffee today. Oh, okay. Yay, we like it. Good. We don't have to go through all of this text. This is just explaining what I showed you. Hi, welcome to Geo Cafe. Nice to see you for the first time. This was just recapping what I explained. Since you're here for the first time, let me just explain Geo Cafe. I'm here to go through geography and any kind of geography concepts. So I'm a high school geography teacher and I'm helping recap any work for anyone who's maybe wanting to learn about geography or is maybe a student busy drowning before exams and needs some help. But it's nice to have you here. Okay, so what this is just what I was saying. You've got the hard rock on the top, you've got the soft rock underneath. The soft rock erodes away, then the water will flow over the hard rock, drop down, and it will just keep eroding. It will eventually create a little plunge pool. So this is when the hard rock falls from there and it falls down and it creates a little plunge pool, and you've got your rocks that just grind around and dig deeper and deeper. Eventually, if this has been undercut so much that this rock keeps falling, that overhang keeps dropping down, then the whole thing will move upstream. Um, oh, I'm sorry. I Please let me know if there's any words that I can try to explain a little bit better. And I know sometimes I speak a bit quickly. But yeah, let me know if there's anything you want me to explain or go through again. Okay, meanders. Wow, a lot of text. I I don't even think we need that much text to explain what a meander is. That's what we need. A nice pretty diagram. Okay. A meander is a bend in the river. I think that's the first feature we have described on this channel. A bend in the river. On the outer side of the bend, you have the cliff. So that's where it flows the fastest. You see it over there. The fastest flow. On the outer side, you've got the cliff. It flows fast. That means it's eroding. On the inside, it flows the slowest. That's why it deposits the material and you get a slip off slope over there. And I feel like I'm missing something. Oh, and it keeps eroding uh, vertically. So it will erode that way and that way. So it will keep getting wider and wider and wider and become more exaggerated. Okay, so this is just another side profile of the meander. You've got the fastest flow over there. That's why you have all the material over there. This is the river cliff or the undercut cliff. This is the slip off slope. So this is where the material gets deposited. And that is the slower side of the river, and that is the faster side of the river. So if you're going canoeing, I would suggest that you park the canoes over here and set up camp over there. Like I said, it was really amazing when I went canoeing down the Orange River because the cliffs on the other side. So when we would stop for the night, we would stop and set up camp somewhere on the slip-off slope. But the cliffs, they're not these diagrams make the cliffs look this big, but these cliffs were massive. They were basically mountains on the other side of the river, and they echoed. So for ages, we were just standing there and calling to the river cliff and, echoing our voice back to keep us entertained. I think we were just tired after a long day of canoeing. Okay, alluvial fans. This is where you have the debris that gets deposited from a river slowing down. So the river will come through here, it will slow down, it will lose its momentum, and it needs to then drop some of the material just to keep going. So as it drops the material, it kind of gets into its own way. So it puts the material in front of itself, and then it needs to move into another direction to find a new place to go. And that's why you have this fan shape, because the river keeps changing direction. Okay, levees. Coffee. Levees. We get natural levees and we get man-made levees. So man-made levees can help prevent floods. Natural levees are formed by floods. We have a river over here before flooding. We have the river flooding, so you can see that the river reaches outside onto its banks, and then it will deposit the material. So because there's a lot of friction on the outside of the bank, it will slow down and it will drop whatever it's carrying. And it will keep depositing that material until it forms a little mound on each side of the river. And that is your levee. So it builds up after many, many floods, and it can actually reduce the chance of flooding or just the impact or the damage of flooding. So typically we find this more like middle to lower course. Okay, then we have braided streams. Braided streams are really beautiful. This happens when a river keeps depositing the material in front of itself. So I like this diagram. So here we've got the river flowing, and if it slows down and deposits the material in front of itself, it splits directions and goes around that material. But it's going to keep depositing the material. So it's going to keep putting more and more and more mud and debris and soil and sand down. So it has to constantly divert its paths and find new paths as it drops more and more sediment. And that's where you get this braided shape there. So it drops it there and then it redirects and then it drops some there and it redirects. Oxbow lakes. Oxbow lakes, really cool features. They form from meanders. So if you have a meander that keeps exaggerating more and more, it eventually becomes so extreme that the water will basically cut off by the meander neck. So here you can see the river needs to go all the way around there and there and there and can come back over here. And this is the outer bend. So you can see if that's a bend there, this is the outer bend there. And same thing for that side. So that's going to keep eroding. It's going to keep eroding until it cuts across. And when it cuts across, it's going to realize that is the easiest path. That's a shortcut. I'm just going to hop over there and it will only flow through there from now on. Then it will deposit some stuff there, and this whole little stream just becomes a lake. And that's what happened here. That's the Oxbow Lake. And when it dries up, it forms a meander scar. I'll find us a few pictures on Google Earth. They're very, very visible scars. You can actually see these brown curves in the landscape. Okay, this is just another diagram for the process. So the red is where it erodes, so fast flow. The yellow is where it deposits, so slow flow. It erodes on the outside there and there, which means that eventually this end and this end, they keep getting closer. They get closer and closer until it just cuts right across. Maybe it's with a flood or something like that. It will cut straight across and it will cut off this part. And that becomes a little lake, an Oxbow Lake. Okay, we've reached the lower course. We're almost at the mouth, almost at the delta. Floodplains. Floodplains is areas where the river will flood into. So if the river floods, it's carrying more water than it can carry. It's basically spills. So it will spill into the floodplain, so the sides of the river, and because it keeps spilling out over there, it will keep depositing material and it will build up these large plains on the side. And it's very fertile land, but floods quite often, so not always recommended for development or farming. In some cases, it's common, especially if the flooding is needed for the agriculture, but not a smart place to build a house. And then finally, our last feature is a delta. The delta you find at the end of the river. It's not always in a sea or a lake. I mentioned that there are a few rivers that do end in the middle of the land, but usually they end or the mouth would be at the sea or a lake. So a delta forms when, once again, the river will put the material in its own path and then it'll have to go around it. And it keeps doing that. So it keeps putting the material in front of itself and it keeps making new paths until eventually you have this big fan shape, and that is your delta. And right here, I have included a picture of one of those few exceptions. So this is a river. This is a river delta that ends in the middle of the land. Does anyone possibly know where this river delta is or what this river delta is called? Quite a well-known one. Okay, that is the Okavango Delta. It's in the middle of Africa, and I'll show you a picture of that now. Well, the satellite image of that now. Let's just first check, is that the slides? Well, since we can't use Google Earth, do you guys maybe know of any examples of various different features? Let's maybe see if we can find Oxbow Lakes. Some of these photos are just stunning. Yeah, that's just a diagram. I don't want another diagram. So that's your Oxbow Lake. I think that was actually a picture that I included in my slides. That one looks really cool. That one's kind of made a heart shape. That's very sweet. And you can see over here how it dried up. So this was where it was flowing and then it dried up and it just kind of took the shortcut right there. And I wonder if we can find one. Oh, that looks cool. This looks really cool because you can see the meander scars. Wow, that's beautiful. So this is the river over here flowing there. The whiter parts of the picture, that is where the sediment is. So that's where it's been dropping the material and it makes like this sandy silt-like material. Then the outsides, that's greener, so that's probably where the vegetation has been growing. And here you can see it there, the river meandered, and here's some oxbow lakes. So obviously there's been loads of oxbow lakes that formed in this area, and all around here, those are the meander scars. So it leaves a mark in the landscape where the river used to flow. That's what I wanted to show you guys on Google Earth. You can see so many good examples of another one. There you go. So there's the river flowing there. And there you can see there's a little lake. That, I'm actually not sure if that's a lake or if that's a scar. I can't tell if the shadow is, or if the dark area is a shadow or if it's water. Here's a scar there. There you can see this patch of greenery between the trees. So that is a meander scar. And what else do we need to find? So we've got, oh, we need to find a braided stream. They're not braided hairstyles. There we go. There's your braided stream. So you can see it drops the material in front of itself and then it has to make these new paths around it. So it has all of these little rivers that split apart and merge together and keep forming new streams. And I do want to just see if I can find a few pictures of the Orange River. The Orange River forms a part of our border. I'll show you over here. So this is where the Orange River flows throughout South Africa. And here it creates the border between South Africa and Namibia. And this is what I meant by these beautiful big mountains on either side. Well, not on either side, on the cliff side. Ah, there, that's the picture I was looking for. Oh, wow. That's a great picture. Please help me out. Oh. I was wanting to show that we kind of have this beachy slip off slope over there, and then we have the cliff or the mountain on the other side. Um, Fortunately, as you can tell, this is a great photo. Oh, I think this is one of the rapids. I'm not sure. It looks like a waterfall, but it might actually just be one of the rapids. Other pictures. No. I guess you're just gonna have to come to South Africa and see it yourself. I can't find nice photos. That one's a nice one. There we go. Please be a decent sized photo. Nope. We go to the website. There you go. Okay, so they've got the slip off slope over here, so that's where they're setting up camp. That's where they've parked their canoes. And then on the other side, you've got this steep mountain aside, so that is the cliff. That would then be the outer part of the meander. That's where you would have more erosion. And then this is the inner bend, so more deposition. Okay. Is there anything else that we need to find? Any other features that we should go check out? So we saw braided streams, we saw meanders, oxbow lakes, meander scars. Um, the We should find a waterfall. Can't not have a waterfall. There we go. There's your pretty waterfall. So there's your resistant rock at the top, and it erodes everything softer further down, so it just falls straight down. And here you can see how this section of the rock, when it eventually collapses, it falls to the bottom and it creates a plunge pool. Oh, I think we have covered all of our features. So thank you for joining me. I hope that you maybe learned something interesting, or at the very least, just saw some nice pictures of the river. And I hope to see you guys back next week. Um, You are more than welcome to mention if there are any topics that you're wanting me to go over. I know many students are prepping for exams at the moment, so very stressful time. If there's a video that we want me to do for revision, more than welcome to leave a note in the chat or the comment section or wherever else. Okay. Otherwise, I hope you enjoyed your coffee and maybe had some questions answered or learned something interesting, whichever it was. And I hope you have a lovely week, and I'll see you guys again soon. Okay. Cheers. Bye.